Good day, engineers. Para sa video natin ngayon, ang i-discuss natin will be the sample problem for the analysis of irregular shaped beams. So let's start the discussion on this sample problem. So ito yung ating sample problem number 1. So from the figure shown, the concrete compressive strength is 27.6 megapascal and the steel yield strength of 414 megapascal. That we have to determine the following. So first is the depth of compression block, second is the actual tension steel stress, and the third will be the ultimate moment capacity of this beam. So yung beam natin as shown is meron siyang ukang triangle on this part. So to solve that one, we have to assume first a distance of A. So it is safe to say na i-assume natin na yung distance A is tatama dun sa uka. So let's say tumama siya dun sa uka at ayan yung distance A. So pwede natin siyang i-3D model na kung saan syempre ito yung dimensions niya and this is A. Tapos syempre yung distance na papunta dito will be the 0.85 of F prime C. So from this figure, we can say na pwede natin gamitin yung equilibrium equation na C is equal to T. So that means the C will just be the 0.85 F prime C times the area of the base, which is an AC or the area of the concrete. That is equal to the AS times the FY. Siyempre, we always assume steel yields dito, which is i-verify din natin mamaya. So from this one, we can get an equation AC is equal to ASFY over 0.85 times dF prime C. So yan ngayon yung magiging base equation natin. Let's take this as equation 1 for our area of the concrete. Now, we have to assume the value of A nga from the above mentioned. So ito na yung figure kung inassume natin yung value ni A. So pinatama natin siya doon sa uka at as you can see, yung uka niya is naging trapezoid, which is ito. So from this one, pwede tayong makakuha or pwede tayong kumuha ng distance X para dito sa isa pang base nung uka natin. So using the ratio and proportion galing dun sa buong triangle kanina, which is ito, we can get a value for X in terms of A. Kasi alam natin that this side or this height is A as shown. Pero alam natin na yung buong height ng triangle na yan coming from our original figure is 150. So ito yung original figure natin, alam natin na yung height na yun is 150. So by ratio and proportion, itong ilalim na triangle is may height na 150 minus the A. So from that point of view, we can have the ratio and proportion as 200 over 150. That is equivalent to a value of the X divided by 150 minus A. And arranging the term, we have a value X that is equal to 200 times 150 minus the A over 150. And simplifying this term, we could get a value of X equivalent to 30 times 10 cubed minus 200 of A or 200A divided by 150. And this is our equation number 2 for the value of x. Now, since we have now the value of x, we can now proceed in uh, getting the area of the concrete na natira, which is ito. Yung inassume natin kung nasan yung distance ni A. So, from this figure, we can say na pwede natin siyang hatiin na ang gawin natin is isang buong rectangle, tapos ibawas natin itong nawala or nauka na trapezoid. So, from that point of view, we can say na yung area ng rectangle na buo is 300 times the A. And then, yung ating value for the trapezoid is yung base sa ilalim. So, i-minus natin siya. So, that will be 200 yun sa taas. So, 200 plus x divided by 2 times yung height niya, which is A. So, times A. So, eto ngayon yung value ng AC natin. And we can substitute yung value or yung equation 2 dito sa equation na to. So, substitute equation number 2. So, we can have the value 300A minus, so 200 plus yung x natin is 30 times 10 cube minus 200A over 150 divided by 2, and that will be multiplied by A. So that is equal to our AC. Ngayon, kung mapapansin natin, yung AC kasi natin dito is may equation na nasa taas. So, pwede natin i-substitute itong equation 1 dito sa equation na to. So, substituting equation 1. So, ilipat lang natin itong figure na to dito. So, substituting equation 1. So, substitute equation 1. So, we can have the value 300A minus, so 200 plus 30 times 10 cube over, or 30 times 10 cube minus 200A over 150 divided by 2 times A. That is equal yung AC na equation 1 kanina, which is A is Fy over 0.85 of F prime C. So, that is A is Fy divided by 0.85 of F prime C. Ngayon, ang wala tayong value is yung AS. So, we get the value of AS by, so that is just, yung rebar natin is tatlong diameter 20. So, that is 3 times pi over 4 times 20 squared. So, that will just be equivalent to a value 300 pi. Now, from this one, substituting all the values dun sa equation natin, we can have 300A minus, so that is 200 plus, so that is 30 times 10 cube minus 200A over 150 divided by 2 times A. Then that is equal to 300 pi times our Fy, which is 414, divided by 0.85 times 27.6. So, doing the shift solve on this equation, we can get the value of A. So, which is A is equal now to a value 99.8512. So, this is in mm. And as you can see, this A is lesser than 150, which is tama dun sa inassume natin na hindi siya lalagpas dun sa uka na triangle. So, yun pa lang yung naprove natin na tamang assumption. Hindi pa natin naprove yung yielding ng steels. So, yun yung next nating kailangan ma-prove. Unless hindi siya mag-yield, so ibig sabihin kailangan natin ulitin yung equations natin mula simula, kasi yung Fy dito na 414 kailangan natin palitan ng 600D minus C over C. So ngayon kunin muna natin yung value ng C. So the value of C will just be equivalent to the A over beta 1. So that is equal to 99.8512 divided by our beta 1 will be 0.85, since hindi naman lumalagpas ng 28 yung F prime C natin. So our C now will be equivalent to a value 14,684 over 125 mm. So this will be now our value of C. So ngayon, from this one, we could get kung mag-yield yung steel o hindi. So this is by using the equation Fs is equal to 600 D minus C over C. So for our sample, yung D kasi natin binigay na niya. So ang D natin dito is yung 430, which is ito. So our D now is 430, so wala na tayong problema. So we'll just have Fs is equal to 600 times 430 minus yung C natin is 14,684 over 125 divided by C ulit, so 14,684 over 125. So our Fs now will just be equivalent to a value 1596.268 megapascals. And this is greater than our Fy, therefore still yields. So ibig sabihin, we can conclude that the A value na kinompute natin kanina will be the depth of compression block or the actual depth of compression block na. Kasi, na-prove na natin yung yielding ng steels natin. So, ibig sabihin, yung first na hinahanap, which is the depth of compression block, is therefore the A, which is 99.8512 mm. So, ito ngayon yung first answer natin dun sa unang pinapadetermine sa atin. So for our next one, hanapin na natin yung actual tension steel stress niya, kasi sinabi din na din dito. So the actual tension steel stress kasi is eto na din yun. Since nag-yield naman yung steel natin and tama yung assumption natin ni A, which is lesser than 150. So wala tayong kailangan baguhin on the part of the calculations. So ibig sabihin, eto na din yung pangalawang answer. Then, yung final na pinapahanap sa atin is yung ultimate moment capacity ng beam natin. So, para magawa natin yung ultimate moment capacity ng beam natin, bago tayo magpunta dun sa pagkuha ng centroid ng depth of compression block or ng compression block mismo, kailangan muna natin ma-check yung net tensile strain. So, unahin na natin i-check yung net tensile strain. So, check for the net tensile strain. So, to check the net tensile strain, we will have epsilon sub t is equal to 0.003 dt minus c over c. So, yung dt natin at saka yung d equal lang kasi single layer lang yan. So, our dt and d is equal. So, ibig sabihin that is 0.003 times dt, which is 430, minus yung c natin na 14,684 over 125 divided by the 14,684 over 125. So our epsilon sub t now will just be equivalent to a value 0.007981. So this is far greater than 0.005, which is we can conclude na yung beam natin is ductile and our reduction factor will be 0.9. So wala tayong kakompute ng reduction factor since automatically the beam is ductile and the reduction factor is concluded to be 0.9. Ngayon, para makuha natin yung ultimate moment capacity, syempre, dadaan tayo dun sa pagkuha muna ng centroid nung compression block natin, which is ito. Syempre, pag nakuha kasi natin yung centroid nung compression block natin, doon dadaan yung compression force. So, ibig sabihin, kung may compression force tayo at may tension force tayo dito, ibig sabihin, makakakuha tayo ng moment arm na makakapag-produce nung ultimate moment natin or the nominal moment muna. So, alam naman natin kasi na from compression, ultimate or the extreme compression fiber to the centroid of the reinforcement, alam natin na diyan. So, that means yung hinahanap nating moment arm will be D minus the Y bar. So, since yun na yung moment arm natin, yun yung kailangan nating hanapin, and mag-uumpisa muna tayo sa paghanap ng Y bar by the Varignon's theorem. So, using Varignon's theorem, kailangan muna nating mahanap yung mga values kagaya ng x at yung x sub 1 dito sa dalawang side. Kasi, hinati na natin ito sa triangle tsaka rectangle. So, yun yung kailangan nating mahanap. So, hanapin natin muna yung value ng x. Si x, yun yung equation 2 natin kanina, which is ito. So, isa-substitute lang natin yung value na nakuha natin for our a. So, that is just 30 times 10 cube minus 200 times 99.8512 divided by 150. So that will be a value of x equivalent to 66.8651. So this will be in mm. So yan na ngayon yung value nung x natin. Ngayon, yung value ng x sub 1 natin is pwede nating kunin as a value x sub 1 is equal to 200 minus x over 2. Bakit ganyan lang yung ginawa ko? Pwede nyo naman ulit i-ratio in proportion na ganito, tsaka yung malaki, tas yung 150, yung height. Okay lang naman yun, parehas lang din naman ng lalabas. Pero mas pinili ko na nakunin to, yung 200 minus x over 2, kasi ang mangyayari lang dyan, ito pwede kong gawing rectangle. So, alam natin na yun yung x. Tapos, divide mo lang ng 2. Yun na yun na yung length ng both side, which is yung x sub 1. So, mas okay na 200 minus x over 2 na lang yung gamitin natin. So, substituting the value of the x dito sa equation natin, we have 200 minus 66.8651 over 2. So, yung x sub 1 natin ngayon dito will just be equivalent to a value 66.5675. At yan na ngayon yung value ng x sub 1 natin. Ngayon, we can proceed in getting the value of our y bar. So, using the Varignon's theorem na. So, syempre, dalawang triangle yan, dalawang rectangle. So, yung dalawang triangle, pwede naman nating pagsamahin yan. So, ang magiging equation ng y bar na natin will be equivalent to, syempre, yung 50-50 dito. So, 100 na yung length nun, yung para sa rectangle. Itong dalawang rectangle na yun. So, meron siyang length na 100 at yung height niya is a. So, that will be 100 times yung a, which is, yung a natin is 99.8512. Tapos, yung distance ng centroid ng rectangle na yan papunta sa taas, so that is just a over 2. So, that will be 99.8512 divided by 2. So, meron na tayo para dun sa dalawang rectangle. Para naman dun sa dalawang triangle, syempre pwede natin pagsamahin yung dalawa. Ipag-add lang natin yung dalawang base nila na x sub 1. So, pwedeng ganon yung gawin natin sa kanila. So, that will be plus. So, that is 1/2 times yung base nila, which is 66.5675 times 2, kasi dalawa yung base na yon, times yung height, which is yung a, which is 99.8512, times yung centroid ng triangle papunta dun sa taas. So, that is 2/3 ng a. So, that is just 99.8512 times 2 divided by 3. So, ayan na siya ngayon. Then, i-divide lang natin to by the total area. So, ang total area natin will just be 100 times 99.8512, tas add mo lang yung 1/2 times 66.5675 times 2 times 99.8512. So, yan na ngayon yung ating y bar. So, calculating that using our calculator, we could have a value of y bar equivalent to 56.5764. So, this one will be in mm. So, yan ngayon yung ating y bar. Ngayon, upon getting our y bar, syempre, pwede na natin gamitin yung equation for the nominal moment capacity. So, which is mn. So, pwede nyong gamitin yung compression force, yung compression side. So, ang tedious nga lang or masyadong mahirap kung compression side pa yung kukunin nyo kasi mag-area pa kayo or magsi 0.85 F prime C pa kayo times the area of concrete. So, much better na nakunin nyo na siya on the tension side. So, ibig sabihin, ASFY na lang kasi yun. ASFY siya kasi na-prove naman natin na yung steels are yielding. So, pwede natin gamitin yung FY. So, RMN now will just be AS times Fy times the D minus our Y bar. So, substituting the value, we have here 300 pi times yung Fy natin, which is 414, times yung D, which is 430. I-minus lang natin si Y bar, which is 56.5764. 64. And this whole equation shall be multiplied by 1 over 1,000 squared. Kaya natin minumultiply ito ng 1 over 1,000 squared para yung units natin is maging kilonewton meter. Kasi remember, this units is in mm squared. Yung 414 dito, this is in megapascal, which is in newton mm squared. Tapos, yung 430 and yung 56 is in mm. So, makikita nyo dito na ang lalabas na units dito is newton mm. So, ibig sabihin, para maging kilonewton meter yan, kailangan natin i-divide yan ng 1,000 squared. So, calculating yung value na ilalabas ng calculator natin, we can have a nominal moment equivalent to 145.7046. So, this is in kilonewton meter. So, nominal moment capacity pa lang to, hindi pa siya yung ultimate. So, we just have to multiply this one to the reduction factor. So, we have here mu is equal to the reduction factor multiplied by mn. So, that will be, our reduction factor is 0.9 times 145.7046. So, our mu for this problem will be 131.1341 kilonewton meter. Ito na ngayon yung ating ultimate moment capacity na hinahanap. So that will be for this sample problem. Nakuha na natin yung depth of compression block niya, yung actual tension steel stresses, and yung the ultimate moment capacity. So again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.